Hey kids, today we're going to be looking at domain and range. So right now on your screen, we've got our first question, and that's what is the range of this relation? You'll notice that there's an assortment of artwork. That is because this creature decided he was going to jump on the laptop and do his little artwork drawing. And he even got a 2 in there, so that's pretty impressive. But let's go ahead and look at what the range is. So excuse the artwork here. Range are the y coordinates. So if you're given a set of coordinate points, you have an x and a y. And so the x is the first number and the y is the second number. So x is going to be domain and y is going to be range. And you have to remember that acronym, Dixie-Royd, that we learned earlier in the year. So Dixie stands for domain, input, x, independent. And so all of those words, independent variable, x value, x coordinate, input, domain, they all are talking about the same thing. That's your x point. Royd, however, stands for range, output, y, and dependent variable. So all of those words are talking about the same thing in your SOL, and that's your y point. So let's figure out what the y point is, because we need the range. 6, 1. I've gone over 6 and up 1 to get that point. To get this point, I go over 1 and up 2. To get this point, I'm going over 2 and up 4. And to get this far point, I'm going over 4 and up 5. So we have to remember that we're looking for range, so that's our y point. And so what we're looking for is a 2, a 1, a 4, and a 5, all the second ones. So 1, 2, 4, and 5. Well, A is 1, 2, 4, and 6. We're not looking for that. B is 1, 2, 4, 5, and that is what we are looking for. So that will be our range. Our second question is asking, what is the greatest value of range? So we're looking for range, and we're looking for the greatest value in the range. When we're given this equation, y equals negative 5x plus 3, and then we're given domain of negative 2, 0, 1, and 3. And so in this situation, you make a chart. Your little t-chart. Your x and y, remember your domain is going to go in your x column. So negative 2, 0, 1, 3. And you're going to plug these numbers in for the x in the equation to see what you get for the range or the y. So negative 5 times negative 2 is 10, plus 3 is 13. I'm going to put the 0 in for x. Negative 5 times 0 plus 3 is 3. Negative 5, I'm going to put the 1 in for the x, that's our domain. Negative 5 times 1 is negative 5. Plus 3 is negative 2. If I put a 3 in, negative 5 times 3 is negative 15. And I add 3 to that, and I get negative 12. So the greatest value here between all of these numbers is the 13. That's our biggest number, our greatest number. And so C is what we're going to be looking for here. Okay, this one of the quicker ones to answer, it says, which relation has a domain of 3, 5, and 8? So we're going to be looking for that first coordinate points. There's 3, there's 5, there's 3. And we have 3s and we have 5s, but we don't have an 8, so we're going to cross that out. 2 is not part of that, so we can cross that one out as well. Okay, we have 3, that's part of it. 5 is part of it. 8, this might be it, but it has a 1. 1 is not part of that, there's no 1 here. A has 5, 3, and 8, which are all part of that, and 3, which is also part of that. Now, it can have more than one 3, that's all right. They don't have to write 3, 3, 5, 8. So our answer choice is A. Now, what is the domain of this relation? In this situation, we are looking for all the x's. 1, 3, -1, and 6. Remember Dixie, domain, and x. So -1, that's part of it. 1 is part of it. 3 is part of it. And 6. So A is the correct answer. Now, the next question is going to be a little tricky, and that it says, get away, that's gross. Okay. And then it wants to know what the domain is of this relation. So we're going to have to plot points. Okay. 6, 5. This is 4, 2. This point up 1 over 6. And this point up 3 over 3. And so in this particular case, our domain are all our x's. 1, 3, 4, and 6. So 2 is not part of it. Again, 1, 3, 4, and 6 is going to be C. Okay, now it wants to know, in this particular question, it says, given the function of x defined by y equals 3x plus 5, the domain is -4. We're going to make that t-chart. If our domain is -4, -1, 2, and 5, what is our range, our roid, our y column? So you just plug these numbers in for your x. Remember, domain is x. So 3 times -4 plus 5, -12 plus 5 gives me -7. 3 times -1 plus 5, -3 plus 5 gives me a 2. 3 times 2 is 6, plus 5 is 11. Can't make a plus sign to save my life today. And then 3 times 5 is 15, plus 5 will give you 20. So in this particular one, you're looking for -7. That's not part of that. It's not part of B. Okay, it's part of C and D. You need a 2. D doesn't have a 2. We need -7, 2, 11, and 20. So C is the correct answer. Okay, in this particular question, we're looking for the domain. So we're looking for 1, 2, 5, and 6. 1, 2, 3, 4. That's not part of it. 1, 2, 5, 6. 1, 2, 5, and 6. Okay. This question's tricky because it wants to know what is not an element of the domain. So we're looking for things that are not in the domain. So -2 is in the domain. That's not an answer choice. 0 is in the domain, not an answer choice. 1 is in the domain, not the answer we're looking for. And 3 is in the domain. So the only answer that is not part of the domain, keyword not, is 4. Our last question, a function of x is defined by the following equation. Y equals 5x plus 12. And what is the independent variable? And so we're going to be looking for the x, because remember, Dixie stands for domain, input, x, independent. It's really that simple. X is your independent variable. Because your independent variable is something you can change. So you can order more pizzas. So that's your independent variable. And the dependent variable is going to be what depends on what you're